Algebra 1, Lesson 54, we are looking at displaying data in a box and whisker plot. So some vocab that we need to know is we want the minimum value, which is the smallest, max is the largest, first quartile is the median of the first half of the data, and third quartile is the median of the second half of the data, which gives us a box and whisker plot, which shows our data divided into 4 equal groups. For our box and whisker plot, this is a typical one that you might see. We are shown a lot of different points. We're shown the minimum, the maximum, the lower quartile, which is quartile 1, median, and quartile 3. So let's find a box and whisker plot for this one, and then we'll answer some questions about it. So I first need to find a few different things. I need the median, I need quartile 1, I need quartile 3, and I need the maximum and the minimum. Sorry, let me get rid of this. Okay, quartile 3, and then max and min. So I need those 5 points to determine my box and whisker plot. So the median, I'm going to cross, or I'm going to put dots just like I would cross them out. Okay, and since these are in order from least to greatest, I can do this. Just go back and forth, and we find that my median is 5. Now I need to find my quartiles, which from our vocab we know quartile 1 is the median of the first half of the data. Well, this is the first half of the data, and when I cross them out, I see that 3 is quartile 1. I do the same thing for my second half of data. I cross out and see that 8 is my quartile 3. My maximum is 9, and my minimum is 1. And so I can now construct my box and whisker plot, and I'll put that down below. So I'm going to have my number line from 1 to 9. And then I'm going to construct my box and whisker plot. So I put a line for each of my median, quartile 1, and quartile 3. So median is at 5, so I'm going to put a vertical line. And then my quartile 1 is at 3, and quartile 3 is at 8. These are kind of the sides of my box, and then I connect the tops to make my full box. My whiskers come from my maximum and minimum. So I put a dot at the minimum and connect it to the middle, dot at my maximum, connect it to the middle. And I have my box and whisker plot. Now, sometimes with a set of data, I might have some outliers. And to determine these outliers, I'm going to have to use these formulas to determine it. Now, to know what these mean, first I need to know what is the IQR. This is the inner quartile range, which is the range between quartile 3 and quartile 1. Now, in our last example, we had our median at 5, our quartile 1 at 3, and quartile 3 at 8. And so I'm going to use these to decide, in the last one, did we have any outliers? Let me just erase a little bit of this. Okay, so in order to do that, let's find the inner quartile range. And that is the range between the third and the first quartile. So we have 5. What we're going to do is determine on the low side and the high side, what would a number have to be in order to be an outlier. So we start plugging things in and we say x needs to be less than quartile 1, which is 3, minus 1.5 times the inner quartile range, which is 5. Which means a number needs to be below 3 minus, well, 1.5 times 5 is 7.5. So to simplify this even more, x needs to be less than negative 4.5 in order to be an outlier on the low side. Since we don't have something that low, we don't have an outlier on the low end. Maybe on the high end. So we say x needs to be greater than quartile 3, which is 8, plus 1.5 times my inner quartile range of 5. I simplified to say x needs to be greater than 8 plus 7.5. So x would have to be greater than 15.5 in order to be an outlier. But we didn't have a number that was that big, so we don't have any outliers in that set. But this is what we would do to determine if we have outliers. So based on this box and whisker plot, let's find what we would have to have in order to have an outlier. So first, interquartile range, we're saying 95 minus 75, which is 20. We take that and multiply by 1.5, so 1.5 times 20 is equal to 30. And then we find the low side and the high side. So we do x needs to be less than quartile 1, which is 75, minus 30. So x has to be less than 45. Or x needs to be greater than 95 plus 30. Quartile 3 plus 1.5 times interquartile range. So x needs to be greater than 125. Since we see that 98 and 65 are my extremes, I don't have any outliers in this data. Okay, let's try it again. So we are going to use that interquartile range, 90 minus 70, so we have 20 again. 1.5 times 20 is that 30. And then we're going to say x needs to be less than quartile 1, so 70 minus 30, which is 40. And on the high side, x needs to be greater than 90 plus 30, so 120. Since we have numbers that it looks like about 55 and 100, we don't have any outliers because we don't have anything that's less than 40 or greater than 120. Okay, let's try another one. So we have this data on some fish populations. And these are the lengths of different fish captured by the California Department of Fish and Game to decide, okay, how big are these fish? And so let's look and find, okay, what are the median quartile 1, quartile 3? And when we do that, we will line them up from least to greatest. I'm not going to do that right now. You can do that on your own. But when we do it, we find that the median is 333. The quartile 1 is 298. And quartile 3 is 511. Okay? Which means that if we were to start drawing this box and whisker plot, okay, and I have maybe 100, 200, 300, 400, 500, 600, and let's say 700. I think that's all I need. Looks like it. And so I can put my median at 333, so about right here. Quartile 1 at 298, so about right there, let's say. Quartile 3 at 511, right there. So I have my box. But I want to make sure that I don't have any outliers because we treat outliers a little bit differently when we make our box and whisker plot. And so we would have to decide, is something greater than or less than? So we find the interquartile range, which is 511 minus 298. And we would say that's 213. So interquartile range is 213. So we're going to say if x is less than quartile 1, 298 minus 1.5 times 213, we might have an outlier. So x has to be less than, let me do this calculation really quick. X has to be less than negative 21.5, which means I would have to have a negative fish length, which isn't going to happen. Okay, and then x needs to be greater than 511 plus 1.5 times 213, which ends up being 319.5. So x has to be greater than, let's see, 800 and, let's see, 319.5 plus 511. So 830.5. Since we do not have fish lengths that are that big, we do not have any outliers. So we can just put our minimum and maximum on here. Minimum being 210, so about right here, and maximum being 722, so about right there. Okay? Let's just try one more example. Okay, these are the 10 birds that were recorded as far as their speed. And we have them in order from least to greatest already. And we can start ticking them off to find the median. Now, I'm showing the full thing of this one for a particular reason. Okay, because when we get down to the middle, we see we have 2 in the middle, meaning that our median is the average of those 2 at 25. When we find the first and third quartile, we are using all of these numbers, including that 24, meaning that we get 22 as our quartile 1. We get 30 as our quartile 3. So when we start our box and whisker plot, I'm going to go by 5s, let's say, so 15, 20, okay, so we have our median at 25, our first quartile at 22, third quartile at 30, then let's see if we have any outliers. Our inner quartile range is 8, which means I'm going to say x needs to be less than 22 minus 1.5 times 8. 1.5 times 8 is 12, so x needs to be less than 22 minus 12, which is 10. We don't have a number that's less than 10, so we don't have an outlier. But if we have x is greater than 30 minus 12, 30 plus 12, we get x needs to be greater than 42 to be an outlier. And I do see an outlier. 47 is an outlier. So this is how I show it on a box and whisker plot. I put a star for an outlier. And then my next one, so 32 in this case, is going to be where I make my whisker. And I'll put my 19 here as my other whisker. Okay? Our outliers need to be shown as stars. Here are a couple other examples that you can try one other example you can try on your own, especially on a calculator if you want to practice that lab. Here's one other. Okay? All right, well, I hope this is helpful for your homework and for studying.